Now, I've mentioned a couple of times here, using indexes in query plans, so the question starts to become, well, how can we figure out what SQL's doing behind the scenes? How can we actually see those execution plans? Well, this is where our query plans, our execution plans come into play. A query plan will allow us to see what's going on behind the scenes, see how SQL is executing a query. Query plans are very helpful for being able to optimize queries as well as to determine which indexes were used by a query. In order to view a query plan, we have two options from the Management Studio. Number one is to view the actual execution plan, or two, to use an estimated execution plan. Now, the estimated execution plan is what SQL thinks it's going to wind up doing. The actual execution plan is what SQL actually did, thus the names. Now, the one thing about an actual execution plan is that it does require the query actually be executed, because in order to figure out what SQL did, SQL actually has to do it. Before we go look at an execution plan, let's talk a little bit about some of the different things that we're going to wind up seeing inside of an execution plan. The first is going to be the method that SQL used to access its data. And there's really two main ways that it can access data, by either utilizing a scan or a seek. A scan means that SQL read every single row in the associated table or index. For example, imagine, if you will, that you wanted to find every single person in the phone book with a first name of Christopher. Now, of course, phone books are sorted by last name and then by first name, so the only option that I would have is to search through every single entry in the phone book. On the flip side, however, a generally more optimal way to view data or to go find data is by doing a seek. With a seek, what will happen is SQL will follow a path directly to the desired data. So to go back to our example, imagine, if you will, we were going to look inside of a phone book for everybody with the last name of Harrison. Because of the fact that our phone book is sorted in the correct order, all I would have to do is flip to the page that had the Harri, aha, there it is, and then we're able to find all of our data that way. So needless to say, that's going to be much faster. As a general rule, you want to see seeks rather than scans in your query. That being said, just because you see a seek does not necessarily mean that that's good, nor just because you see a scan does that necessarily mean that it's bad. That there are going to be times when it would actually be faster for SQL to look through all of your data. Seeing a scan should give you maybe a little bit of pause, but it should not necessarily be cause for great concern. Let's see a little bit of this behind the scenes. I'm going to fire up my Management Studio here. Open up a new query window. Use AdventureWorks. And then let's create a query. And so what I'm going to do is I'm going to say select, and let's say first name, and then last name from person.contact, where last name equals, and let's just go ahead and use my name of Harrison. Now, if I want to see the execution plan, here inside the Management Studio's toolbar, I've got two different buttons. The first button that I have is the Display Estimated Execution Plan, which will, of course, get me the estimated execution plan. And then I've got the Actual Execution Plan, which will give me the actual execution plan, and that's the one that I want. So I'm going to click that, hit F5, and then now if I click on my execution plan, that will show me the execution plan. Now there's a couple of little things that we wind up getting inside of here. First of all, you're going to notice down at the very bottom where it retrieved our data from. So in this case, it wound up doing a clustered index scan. Now, if you remember, a clustered index is going to be the order of all the data in the table. So essentially, this is a table scan. Generally, that's going to wind up being bad. The other very big thing that you're going to notice is that it even told us the fact that, hey, if we created an index, this query would execute faster. Now be very careful about using that for creating your indexes, because this is sort of executing in a vacuum. That the only thing that it's truly concerned with is just this query, no other query. So just because you created this index doesn't necessarily mean that you're truly going to be optimizing SQL Server, that yes, I'm going to be optimizing this query, but I might be slowing other queries down. So again, this will execute in a vacuum. Now let's see the change that we would have if we added on that index. So I'm just going to do a real quick right click and I'm going to choose Missing Index Details. You'll notice that it already has the script for creating my index. So all that I would have to do is just give this a name. So in my case, this is going to be IX contact and then last name. And then I'm just going to highlight that section and execute that. Now, don't worry too much about the syntax here. That's really not the purpose of the discussion. What I just want to focus in on is the fact that we can create the index based on the instructions that we got. So that's all I'm doing here. Now I'm going to go back to my original query window. Let's go ahead and execute this again. And now you'll notice that things behind the scenes have changed. You'll notice that we're now actually utilizing two different search methods. The first is what's known as a seek. Remember, that's going to go in and look for the appropriate data. And then the second is a key lookup. If you remember from our little example from before, we don't have all the data inside of the index. If I go back to our little screen over here, I want to highlight the fact that we only created the index on just the last name. Well, our query, if you remember, asked for first name and last name. Well, in order to go get the first name, we have to go back to the table. That's what the key lookup is doing, is it's going in and it's pulling up all of the first names by the keys that it retrieved from the other index. You'll also notice that it's joining them together, which begs the next question. Well, how is it joining them together? What are our join methods? I'm glad you asked. SQL actually gives us three possible join algorithms. The first of which is a join merge or a merge join. A merge join is optimal because what that means is that my data is pre-sorted. So when we're creating that seam data on the left and on the right is automatically, or already, I should say, in the correct order. Merge joins, good. The next type of join that we have is what's known as a loop join or a nested loop. A nested loop is going to be used when one table is much smaller than the other, and what will wind up happening is that the smaller table is going to be searched for the values that match the larger table. A loop join is going to be slower than a merge join, but again, not necessarily going to be an indication of bad performance. And then finally, last but not least, is a hash join. And a hash join is going to be used when we have large tables and those tables have unsorted data. Now again, a hash join is going to be the slowest type of join, but again, just because you see it doesn't necessarily mean that that's bad. If we come back to the Management Studio, what you're going to notice is that we happen to have used, or SQL happened to have used, a nested join behind the scenes. Because essentially, that's what we had here. We essentially had two different data sources. One for our index, that's the index seek that you see, and then one to actually go back to the table and go retrieve the first name. That's the key lookup that you see. And when we retrieve data from two separate sources, that always has to be joined together. So even though we didn't actually execute a join, SQL still used a join behind the scenes.